Okay, this is 2.1 of algebra. Equivalent equations are equations that have the same solutions. So you don't need to write this down, but the addition property of equality just says that we're allowed to add 3 to the left side if I add 3 to the right side. If you need to, when working with equations, stick a line down the equal sign to make sure that you're adding to both sides. Same thing with subtracting. I can subtract 3 from the left side if I subtract 3 from the right side as well. When we think of equations, we need to think of them as a balance. When they give it to us, it is balanced. I can't only add 3 to the left side because that'll throw my scale off. I have to also add 3 on the right side. Okay, when we're solving equations, we isolate the variable. We get the variable alone. And we do that by using inverse operations. So if I'm multiplying, I need to divide. If I'm currently adding, I need to subtract. I need to do the opposite operation, or the inverse operation. Alrighty, so let's look at our got it problem. What is the solution of y plus 2 equals negative 6? So I'm going to draw a line down the middle so I make sure I do the same thing on both sides. I need to get y alone. Right now I have a plus 2 next to it. So I'm adding 2. To get rid of adding 2, I need to subtract 2. So I subtract 2 from both sides. That'll cancel out. And I'm left with y equals negative 8. Then I can plug my answer back in and check it. So my equation is y plus 2 equals negative 6. I can plug in negative 8. Negative 8 plus 2 gives me negative 6, and negative 6 is equal to negative 6. Alrighty, I'm going to solve equations again. This time I'm just using addition. So I have m minus 8 equals negative 14. I need to get m alone, so I need to add the 8 to both sides. I was subtracting. The opposite of subtracting is adding, so I'm adding 8 to both sides. Whoops, that'll cancel off, and I get m is equal to negative 6. I'll do this guy over here as well. I'm trying to get the y alone, so I need to get rid of the 3 halves. So I need to add 3 halves to both sides. That'll cancel off. I get y equals 3 halves plus 1 half is 4 halves, which is just 2. So y is equal to 2. Okay, again, you don't need to write this down. The multiplication and division properties of equality just say that if I multiply by 3 on the left side, I have to multiply by 3 on the left side, or on both sides. So whatever I do to one side, I need to do the other side. That stays with multiplication and division as well. So let me draw my line. I have 10 equals 15x. Right now, there's multiplication happening between that 15 and the x. It's 15 times x. The opposite of multiplication is division, so I'm going to divide by 15 on both sides. And that gives me x equal to the fraction 10 over 15. Or if I divide the top and the bottom by 5, I get x equals 2/3. We'll skip that guy. Okay, multiplication, same sort of deal. Right now I have 19 equals r over 3. Right now r is being divided by 3. The opposite of dividing is multiplying. So I multiply by 3 on both sides. 3 and this 3 cancel off. So I get r equals, and 3 times 19 is 57. So r is equal to 57. Over here, if I were to do this equation, x right now is being divided by a negative 9, so I need to multiply by negative 9 on both sides. Those would cancel out, and I'm just left with x equals negative 72. Make sure if you're dividing by the negative, you need to multiply by the negative, because a negative times a negative gives me a positive. Okay, the reciprocal of a fraction is when we flip it over. So if I have the fraction 4/5, its reciprocal is 5/4. So you just flip the fraction. And when we're solving equations that have fractions in them, we're going to multiply by the reciprocal. And I'll show you why that works. So I have the equation y equals 3/4 x.